Hello children. After studying Oster's experiments, we knew that field lines are produced around the current carrying conductor. Magnetic lines of force is there around the current carrying conductor. Now we will study to find the direction of a magnetic line of force around a straight conductor. So for that, first of all, let's study the activity. Then I will explain the rule to find the direction of magnetic line of force around the current carrying conductor. Now let's see that one. We have a cardboard. On that cardboard, we make a hole and pass a conductor through that hole. Then we connect the conductor with battery and switch. Now in this conductor, the current through the conductor AB, current will flow in downward direction. Okay, this is just our setup. So now we will keep a magnetic needle near the conductor. We will find nothing happening with the magnetic needle. It will align itself as usual in north-south direction. Now we switch on the current in the circuit. Again we keep the magnetic needle here. Then we find that the magnetic needle, north pole of magnetic needle starts aligning itself like this. We mark the two end of the magnetic needle. Again we keep magnetic needle just ahead it. Again the north pole moves like this. Again we keep magnetic needle here. Again north pole will align itself like that. So as a whole, what will happen that we will get a circular path, circle around the conductor. And also we notice that the north pole of magnetic needle moves in clockwise. Again we keep magnetic needle at some more distance from the conductor, and again we try to find the direction of motion of north pole of magnetic needle. We find that the magnetic needle, north pole of magnetic needle moves in clockwise direction. Okay, now from this one we become confirmed that really there is magnetic field around the straight current carrying conductor. Due to that the magnetic needle is moving along the circular path. Otherwise there was nothing over there so that it could change its direction. अब क्या करते हैं, ये मैग्नेटिक निडल को हटा दिया और कंडक्टर के चारों ओर हम क्या करेंगे, आयरन फाइलिंग्स स्प्रिंकल कर देते हैं और देन वी स्ट्रक द कार्डबोर्ड, उसको धीरे से वो स्ट्रक करते हैं, ठोकते हैं. देन वी फाइंड दैट आयरन फाइलिंग्स अरेंज themselves along the circular path. Okay, now again we take what we do, we connect the two end of conductor with battery and switch by changing the polarity. By changing the polarity means now through the conductor current will flow from B to A in the conductor. Again we keep magnetic needle around it, and then we try to find out the direction of motion of north pole of magnetic needle. We find that the north pole of magnetic needle moves in anti-clockwise direction. North pole moves like this, and again we get circle around the conductor, and that is the direction of magnetic field around the conductor. Again we keep magnetic needle at some more distance from the conductor. Again we find the circle in which magnetic needle moves in anti-clockwise direction. Again we remove magnetic needle from there, and then we sprinkle iron filings around that. We get the concentric circle around the conductor. So in both the activities, what we found that when the current through the conductor flows in downward direction, then magnetic lines of force are clockwise, and when current flows in upward direction, then the direction of magnetic field is anti-clockwise. Okay, and also sprinkle iron fillings around the conductor. We find that iron fillings arrange themselves along the circular path, and iron fillings have magnetic domains. Already I have explained in the first video. So they become a magnet, they behave like magnet, and then they arrange themselves in clockwise or anti-clockwise direction. Okay, so these were the two activities in which we studied that when current flows through a straight conductor, what will be the direction of magnetic line of force around the conductor. For finding the direction of magnetic field around the straight conductor, we use Maxwell's right hand grip rule. So what Maxwell's right hand grip rule tells that if we hold a straight conductor in our right hand such that the thumb represents direction of current and the wrapped finger represent the magnetic line of force. Thumb represents direction of current, thumb, and the wrapped fingers represent the direction of magnetic line of force. It means direction of motion of magnetic needle. So in first activity, current is flowing in downward direction, wrapped fingers are in clockwise. So the direction of magnetic line of force around this conductor will be clockwise, and that in this second activity, direction of magnetic line of force will be in anti-clockwise direction. Okay, so again let's recall Maxwell's right hand group rule or Maxwell's right hand thumb rule. If we hold a conductor in a right hand such that the thumb represents direction of current, then the wrapped finger will represent the direction of magnetic field around the conductor. So finally, these things we understood from this activity, that when current flows through a conductor, a straight conductor, then magnetic line of force are produced like the concentric circle. So many circles having same center here conductor. So concentric circle like magnetic line of force are produced, and when current flows in downward direction, magnetic line of force will be clockwise. When current flows in upward direction, magnetic line of force will be anti-clockwise direction. Again, the factors on which the strength of magnetic field produced around this conductor will depend are that as the magnetic field is produced due to current, so if the strength of current increases, then the strength of magnetic field increases. Suppose if the current is doubled, tripled, like that, strength of magnetic field goes on increasing. Next one, if we move away from the conductor, it is obvious, everyone can say without studying also, that if we move away from the conductor, strength of magnetic field will go on decreasing. So these things we studied in this topic, and now in next video we will study the magnetic line of force around the circular loop. So children, understand these topics. These are in your syllabus, and revise nicely and have the better concept. For that I am working hard. Watch the video and subscribe also If you have any difficulty, write in message box. I will see that one and then answer. Thank you so much.